Hello, everybody, and welcome to the next stage of our Revit Structure webinar series. Today, we will be presenting steel connections with Revit Structure. It forms the fourth part of our Revit Structure webinar series. Thank you, everybody, for giving us your time today. We'll start off with the benefits of 3D modeling for your steel connections. So again, based on the answers to those polls, hopefully there's some lessons learnt there for a few people listening in today. We'll move on to a typical Revit workflow that includes steel connection modeling, and then we'll get into the demonstration of various standard and custom connection types in Revit and some of the parameters that you'll have available to you as well, and how you can turn those connections into drafting production as well. So I will push ahead. My name is Ben Hipsley. I'm hosting the session here today. I have my colleague Asif with me as well. He will be taking care of the technical presentation portion of today's webinar. Okay, I will get into it and discuss the benefits of a 3D modeling of your steel connection. So I'd like to start out with a bit of a head scratcher for everybody. So I want everybody just to think about the last time that a connection detail that you might have created caused any type of delay or an on-site issue. Now imagine if every bolt, every weld, every plate had already been coordinated in a 3D model before a single piece of steel was cut. So that's what we're really talking about here today, and that's the challenge that we're going to try and solve for people here today. So when designing steel connections in 2D, we can certainly talk about the challenge that comes from designing complex geometry, from translating that from a 2D plane and the detailed documentation, the difficulty that can come through analysis, and also just the sheer time it takes to design and draft dozens of different connection types across a project. So even if we are duplicating connections through, say, a truss or a bracing system, we then run into QA challenges when a design change is made and then has to be manually translated to all the duplicated sections. So when modeling connections in 3D, many of these challenges are solved, but honestly, these are just some of the basic benefits that are gained from modeling connections in 3D. I'm sure many of you are already aware of these. A lot of people somewhat solve these challenges by building a DWG database over time of all different connection types, which can then essentially be dragged and dropped into new projects. While this certainly does solve some challenges, it doesn't provide the real benefits that modeling steel connections in 3D can provide. And these are the ones that I just want to quickly touch on now. So a single connection update in the model will automatically propagate to all associated views, so plans, section, details, and schedules. This ensures the accuracy and consistency of your drawings and reduces the likelihood of any issues or RFIs being raised by fabricators or on-site. You can also use interference checks to identify clashes between your steel connections and other elements such as MEP or walls. These are identified in real time during the design phase, well before they become an issue on site. Further to this, a 3D model will provide far more context on the constructability of your connections, particularly when we're dealing with welds or maybe bolts in tight spaces. We can also maintain codes and standards throughout our connection design. For example, your plate edge distance from bolts can be governed so that if any bolt sizing, spacing, or positioning is changed, the required plate edge distance will be maintained as well. And finally, while it's still in its infancy in Australia, more and more infrastructure projects are mandating BIM and digital engineering workflows. So by adopting this now, you stay ahead of the game, ensuring your business remains competitive and ahead of the game. Okay, so I just wanted to provide a brief overview of a typical Revit workflow for a structural project that would incorporate steel connection modeling. So the upcoming demonstration will focus more on the actual connections. So I just wanted to touch on what part of the workflow today's demonstration will fall into. So for a structural project, we will always start with modeling the frame. We can then import or load the standard as well as any custom connection types. We can then place them before adjusting the parameters and the settings for that individual connection, and we then propagate it out to all similar elements. There are a number of options to then run clash detection for your connections, and once we're comfortable in our modeling, we then start the drawing production and exporting out to fabrication or IFC. So in today's demonstration, we'll see a live example of how to manage the connection types within Revit, how to place and propagate the connections across your model and adjust the parameters to suit. And we'll also move on to the drawing production. The other parts of this workflow have been covered in some of the other webinars in this series, but if you would like more information on any of them, please get in touch with us. So I'll push ahead now into today's live demonstration. So I'll hand things off to Asif, who will be able to pull open a few models and show us some really great interactive connection design within Revit. So Asif, I will hand across to you.
Well, thanks, Ben. Can I share my screen? Please can't share. Ben, can I? Oh, yeah. Just wait. All right. Can you see Ben properly? Is it coming?
Yes, it is. Asif, you're all good.
All right, thanks, Ben. Good afternoon, everyone, and welcome to the webinar, Steel Connections with Revit Structure. My name is Asif Hossain Khan, and I'll be the technical presenter today. I work as a structural application engineer and structural drafter in CSS. Now, steel connection in Revit is basically procedural in nature. By procedural, what I mean, for example, if steel members are aligned at a particular angle and you apply connection, then upon changing the alignment or changing the cross-section of the member, the connection is going to adopt automatically. There are 131 procedural steel connection exist in Revit. Today, we may not be able to bring all 131 connections in front of you, but we'll be exploring some of the major connections, how to modify to suit your need, and we'll look how the documentation is done effectively when change occurs without doing any manual line work. All right, we have a lot to cover today, so without further delay, let's get started. Okay, as you can see, this is on my screen. There's a model over here. If you're wondering how did we do that, if you couldn't be attend our first webinar, there we have modeled entirely this project, and we also showed how the documentation is done, how the scheduling is done, and everything is pretty much automatic. And that's the webinar was called Migration from AutoCAD to Revit Structure. Okay, great. I borrowed that model, and from the yesterday's presentation, I borrowed some of the options over here. And for this project, we actually had to put another level over here to support the tanks. Okay, great. In case of steel connection, that exists on the steel tab over here. And before I go on, I would like to talk about the setting for a few seconds. If I click on this arrow button, this small arrow, which is called connection settings, it will open up a connection settings, and you have a different connection group over here you can choose from, or otherwise all those connections, all 131 connection will be on your left side if you're opening this one for the first time. Now I have selected all and push it on the other side to load all the connection in my system so that I don't have to wander around that, okay, go for the connection to connection, bring it in, load it in, and that's going to kill my time. That's why I brought all the connection on this side. All right, press OK. Now, as I said that we may not be able to cover all of the stuff, but the major stuff I'll show, which is structural connection. And once you put your mouse over there, it's going to show you a cool graphics. And over here, you can see some sort of line, some texting going on within the circle. I'll explain it whenever it's necessary, but for the time being, so if you click on the connection, your connection is ready. Now it's asking you to put some connection on the members. Now, if you click on this type drop-down list, you'll be seeing all the 131 connections because, as I already have showed you, I brought all the connections in my system. All right, great. So probably we'll be starting from the base plate. So once I click on the base plate and click on this column and press spacebar, it will create a base plate for me. And probably this is the default setting. That's why it's coming like this. Now, to change the default settings, what I'm going to do, I'll select the connection and go to the edit type. Once I press edit, it's going to give me a connection setting. And here on the left side, I will be able to see some sort of preview. And I have the options to change 3D, 2D, plan view at the level and back and forth. Anyway, on the modify parameter, this is the interesting part to change anything. So if I click on this modify, it'll come up on my screen. And as you can see now, there are three parts basically. One, I have already talked about the 3D view, plus this middle section. This is the turning point. Every parameter, every connection has some sort of parameter built up already, because I already have said it's procedural. And just imagine 131 connection and how many parameters could be over here. So it's really not possible to go each and every parameter today. You can just play around once I show it how to control it, once you have an understanding. All right, let's go for the base plate and base plate layout. The first thing you'll always see, it'll be telling you that base plate thickness. And this is the reason I put my 3D view over here, because it's going to show me real-time preview. Now, by default, it's coming as a 25 mil plate. If I change it to 20 mil, you can see it's updating. Let's say the update is not that much. So if I say 4 mil plate, as you can see, it's getting so narrow. Now 20 mil plate, and there it is. My 20 mil plate is done. Now for the layout, we have several methods over here: projection, total, from center, from by anchors. Now, instead of exploring everything, I'll go for the projection. And once I select in projection or any of this drop down, you'll see there's nothing coming out. The reason it's not coming out, because it is loaded here. Base plate dimension. Because I chose projection, so it's showing me the projection projection parameters, all the projection. Now, in all sides, I have given a tick mark. That's why it's grayed out rest of the parameter, and only showing me number one parameter over here, which is the projection. Now, if I go back a bit, and I'd like to talk about this graphic at the right, it is presenting the parameters. What you can see, this is number one, and that number one is coming over here, which is the plate thickness. In the same way, if I do not say, if I do not put it like equal, then you'll be able to say that parameter number 1, 2, 3, 4, which is already described here, is activated. Now I want equal parameter all over the place. That's why I'm ticking this on. And let's say I want 100 mil projection on all sides of my column, and there it is. My 100 mil projection is done. Now, if you have something different in mind, just tick this off and then start playing around which side you want longer, which side you want shorter. It will come up automatically. I want everything equal, so everything. All right, also you have the plate corners to do. There are a bunch of parameters over here. If you want to do fillet, cut, convex, and none, everything is there. So you just have to play around to suit your need. Anchors and holes. What type of anchor? What is the size? It's loaded here, and there's a heaps of anchor loaded over here. You can choose at your particular anchor if you have anything in your mind. All right, now washer plate. I'm not going too fussy about this one, because you got the idea how to control this. I'm directly going to my number of anchor control. All right, great. We have two parameters, basically parallel to web, parallel to flange. Now, by default, it's giving 2. If you change this to 3, you'll be able to see there are 3 anchors. If you change it to 4, it will become 4 anchors. Definitely the size intermediate distance is not correct. You have to change it from here. Probably that's not your settings. Probably 3 was better, and that's how we control anchor distance. Now I'm reverting it back to the default settings. So in this case, for example, I want the anchor on the other side, not on the flange side, but along the web side. So I'll go over here and then on the next parameter, and that will be giving us cool graphics over here. So from here, you can understand that which side, which direction, and which parameter we're talking about. And those are listed as a numeric value over here as well. Okay, probably on this part, I want 3, and upon placing 3, the distance are not correct. So I'll place 175, and there it is. My distance are right. You also have the offset from the center option. You can play around and you can have a look how does it come up for your project. Let's say this is my requirement and I have finished my model, and press OK. And press OK, and there it is. My connection is perfectly sits under the column. Now, this column, this is basically, you see, this column exists 5 more places. Now, you don't have to, when you're working with a connection, you don't have to just manually do and go on every column by column. You have easy system, select the connection, and then upon right clicking, it will show you propagate connection. Now, this propagate connection, what it's going to do is going to see the same condition. If it exists in the 3D world, it's going to put the same connection all over the places. As I already said, that this connection was repeated 5 times over this, as you can see from the color. So I'll right click over here and say propagate connection, and upon clicking over here, you'll see some sort of flashing on those columns. Have a look. There is a flashing going on, and your connection is placed with ease. No manual work, no line work, no nothing, and everything is done with automated system. And if you change anything over here, all of these connections which are using the same, from the name you can understand this is a base plate, everything will be changed. So this is a part to remember, because I'm going to do the same thing over on the other column. We have some more columns over here. This is 310 UB, and these are 410 UB. Now, if I use the same connection on the UB, watch what is going to happen. I'm going for the steel tab connection, select the column, press the spacebar, and as you can imagine, the dimension and size are not correct at all. The reason it's not correct at all, because of the projection settings we have done for this particular connection. It's trying to replicate over here, which may not be the right choice. So for that, what we usually do, we select this, and and go to the type parameter, type window box, and then instead of changing directly from here, you always duplicate this one. Because what is going to happen if you change this one, this is the base plate one, it's going to change all over the places where you use the same base plate. Now, it's always a good idea to duplicate and then change it. Now, in my type drop down, I already have made 3 different base plates, one for 310 UV, one for 410 UV. I'm going to show you what the difference is going to be. If I click it over here, you'll be able to see in the 3D view how is it updated with the same base plate, with the same settings. Probably a bit different parameters adjustment was done, plus a few stiffener along the flange I have attached. Once I placed OK, now as you can see, this base plate is no longer the same like other base plate. And that's the beauty of parametric modeling. You create one, then you replicate, you change it, and that replication will be recorded properly, and you can use it in the multiple locations. Now, let me show you. Once this is done, definitely you can imagine what I'm going to do right now. Select this base plate and right click and propagate connection, and the flashing will come up on the same condition of the member and the same size of the member, and my base plate is done. Now I'm going to show you a bit more over here. If I get inside, okay, let's not do over here. I'm going to show it on the other column. Let's do it on this column. I'm taking my connection, and upon taking connection, it's asking me what is the column or what is the member. If I come to my drop down, as you can see, I have already talked about that I created 3 types of base plate. 2 are done before I have started this webinar, so that I can minimize the time of doing the repeated stuff. So this time I'm going to use 410 UV, select it. Its name is coming out as a 410 UV. These are my 410 UV, select, press enter, and job done. And these settings were predefined, pre-built. And now I'm going to show you where to adjust this. In the first connection, I didn't put any, what is that called? Stiffener. So in this connection, you'll be able to see there's a stiffener and plate section where you can adjust leveling plate, shim plate, shear anchor dimensions are also over here. Web stiffener, flange stiffener. I mean, heaps of parameters over here. You need to just explore them. You need to understand, practice them basically to know that which parameter does what. And there's a cool graphic on the right side. You won't be, you will never get lost. So over here, I use the flange stiffener, as you can see on both sides. If something is grayed out, it means that I'm not using anything at all. Outside, I haven't used that. If I tick it, then everything will come up live. Now, stiffener plate uh, on the other side, this is called stiffener plate preparation, weld preparation. This is basically what kind of welding do you want, and all the detailing over there. I use the middle stiffener, which you can see over here, a bit of adjustment of the size and shape of the stiffener, and there it is. My stiffener is ready. Now, if you have anything different from this base plate, you can just play around with the base plate settings and everything is in your hand. All right, press OK and press OK. Now I'm going to replicate it one more time. Select propagate. I'll choose this one so that I can see that there's a flashing going on. Propagate, and the connection is propagated, and there it is. So different connection I placed at the different columns condition. Now, if you think that, okay, what is going to happen if I use the same connection over here? Yes, it's possible. You can use this base plate on this column as well. Let's say what happens. I'm going to match up from here to here and press modify, and there it is. My base plate connection is changed. As I said, that these are procedural connections, so this is going to identify the size and shape and change and boundary condition and change accordingly. Now, probably this is not the ideal case for this column, so I'm going to revert it back, select it, and from the drop down list I will use 310 UB, and my job is done. Very nice, very easy, and very easygoing. So you don't have to be scared about this one. Just you need to invest your time, understand the 131 connection if you can. Otherwise, you just play around with the connections and whatever. If you're using repeatedly in your project, you can just play around and get them ready so that at the time of the work, you can just directly input it. Okay, great. The next thing I'm going to talk about is the apex connection. All right, let's do it. So apex connection at the rafter. So I'll be moving a bit faster because, as I said, I cannot go through all the parameters of all the connections for the sake of the timing of the presentation. So go to the connection. Over here, you chose whatever is necessary. Over in this condition, I need apex hunch. Select these two apex hunch, press spacebar, and then your job's done. Now again, right click, propagate, propagation will be done. And as this connection is replicating over and over, if you change anything, going back to type and modify the parameter, it's going to reflect on every single type that you have been using in this project. If you have something different, for example, the middle one is something different from the exterior one, just select again in the type parameter, duplicate. You must do it, duplicate, change the parameter, then come back and use it, like what I have done for the columns. Once this is done, I'm going to move for the knee connection over here. So rafter and column, I'll go to connection, look for the connection type. If you're having difficulty, if you know what kind of connection type you're looking for, just type it in over here in the search bar. If you cannot do that, go for just scroll down and look for the cool graphics was presented over here. What kind of uh, connection you're looking for? Probably these are gonna be a bit helpful for you. Other than that, I'm gonna write down knee, and there are my 3 knee connections just came out. I want to use the second one. Select column, select beam or rafter, and there it is. Now it's time to talk about these lines, which I haven't talked about at the very beginning. The reason, because we have been using just one connection and there are only one member associated with it. Now it's a good time to talk about this one. When you select 2 or 3 members or the many members, then what Revit is going to do, Revit is going to identify those lines, basically the center line of the member, and keep some line drawing at the end. What type of, is it a secondary member? Is it a primary member? Is going to give you some sort of feedback over here. Now, the primary member will always have the circle field over here, but the secondary member will have some sort of numbering, let's say, for example, 2, 3, 4, as it proceeds. Now, if I switch this from the primary to secondary, what's going to happen? And this small dot is going to make it primary, and the entire arrangement is shifted from one side to another. Now Revit understands this one is a primary, so I have to use my hunch in this fashion, and I have to replicate it into different orientation. Now, probably this is not the ideal condition. I'll keep my primary as a primary on the column, and you have complete option to going to the edit type and modify parameter. I'm not doing the same thing repeatedly. You can play around all day long. All right, great. Select and propagate the connection, and there you go. There's a flashing going on, and your connection is done. Now the third one, sorry, this was the third connection. The fourth one I'm going to talk about, which is the purlin connection. All right, let's do it, purlin connection. Now, let's say we don't know what kind of connection we're going to use. I just selected a connection, and by mistake, for example, my knee hunch connection is selected. If I select the rafter, select the purlin and press spacebar, now it cannot detect anything that matches with this connection system. That's why it's giving you a warning message over here. But no worries, if it's giving you a warning message, the reason is it cannot find the proper condition. That's why it's coming up. So select the connection, and from the drop-down list, let's say I want a tertiary connection like this. Once I click it over here, there it is. My tertiary connection is placed with ease. Now, again, you may need to play around with the, select it and play around with your settings over here. Otherwise, if it's okay, then you can just keep going on and on and on. Okay. Excuse me, I just deleted my connection. Let me put the connection one more time over here, selecting the right connection, selecting the connection, coming back to my type and going to the tertiary connection, which, if you cannot find it, sometimes I get lost. Tertiary, and you will be able to see there are tertiary connection. Select the rafter, select the purlin, and there it is. Again, right click, propagate. It will be propagating on every single point. As you can see, it may take a bit of time, number of connections and number as your system, depending on your system, it will take a bit of seconds to load it and place the connection. Now, this time, as you can see, the bolts are not at the right place. This is because it's coming as a default one. Again, go to the modify parameter and change it as you need. Now, in this case, I'm gonna discuss something different. You're not limited to this connection only. You also have the provision for using, let's say, purlin connection. Sorry, tertiary connection. Let's say these are the connections. I'm talking about single tertiary plate. If you click on that, that's going to give you another option. So you can select the connection, and you can play from this list as you go on. All right, great. Probably this is not the ideal connection or ideal condition. You can change the parameter to suit the beam size. Okay, great. I already have pre-built, pre-made some connections over here. Let me explore one by one. So let's say this is not the thing you're looking for. You also have an option to change a long plate like this with two bolts, and probably this is the thing you do in your day-to-day life or everyday life. You can just click it and select it from the drop-down list. And again, I created one, and then I modified and I recorded this into my system. That's why it's coming as a list over here. For example, I need some different plate. So plate arrangement can be altered like this, and everything is recorded in your modify parameter section over here. So edit connection type. Okay, great. Now I'm going to switch it to something different. Let's say it's without web. So you also have the provision of putting the stiffener. Uh, it's not called stiffener, it's a rib. Okay, it's called rib or stiffener, whatever you'd like to say. You can put it, you can take this out, and everything will be working according to your need. Now, if you have selected this one and you want to do in all the connections of the purlin, select all the purlins and then switch it back to, let's say, 6 without web, and within just one click, your job is done. Now, if you're not happy with this, and select all of them, probably you need a bit of rib over here. Select the rib, and there it is. It's going to take a bit of time. All right, done. I have also made some 10 mil plate with rib, without rib. You can just play with these settings all day long. Okay, great. The next thing I would like to talk about, let's say something different, like this column is connected by 2 beams over here. Oh, there's a connection exists over here. I'm going to delete it. I'm going to show you later on how to do this. Before that, I want to attach these 2 beams with the column. Now we have many connection system exist over here. What specific I want to show you, which is called double-sided. I'll go for and search for double-sided double-sided end plate with safety bolt. Once you place it, select it, and then select the primary member, then the secondaries, and press spacebar. And as you can see, already I have explained about these handles. So I'm not going repeating the same thing. And there it is, my safety bolt is placed with ease. Now, if you are not happy, again, you have the choice of making any other connections from here. And it's just a matter of going over here and then changing the parameters, and that will become up like this. I guess you got the idea. So again, once you do this, probably this is not the ideal connection. You change it from the modify panel and then you replicate it. It will see the similar condition where the column and this beam exist, and that will be replicating all over the place. All right, next one, I would like to talk about the connections like this, where the flanges are coming on the web, and also the beams are coming and attaching on the flange and the web. So in this case, you can use some different connection system, which is called we usually call this clip angle. If you search with the clip angle, there it is. My clip angle is there. If I select it and place it, column, then beam, spacebar, there it is. My clip angle is placed with ease. All right, great. Again, as I already have told you that I need to adjust some parameters over here because of the size and shape, it may coming a bit funky like this, but you got the idea that how to place this easily. I'm going to use the same plate and connection on the other side. If you want, then I could select it, select the beams and press it, and there it is. If you're not happy, then we go to the connection type, and then we may need to adjust some parameters over here, which is the vertical bolting. Let's say the bolt distance is 76. In this case, we want 65, and you'll be able to see how is it updating over here. When it was 76, it was like this. So bolt distance was 65. That was chosen by engineer, and it adopts the size and shape. Also, how far from where the angle is going to start, it's going to be detecting from here. Set out, and your set out is basically giving you a cool graphics from here. Set out from the middle, from the section, from the top of the bolt, from the top of the flange. If I set it middle, everything is got in the middle section, and press OK, and there it is. Apply. Press OK. Your connections are updated automatically. Now you have many different parameters. Now you just have to explore those parameters at your own time. Okay, great. I'm not moving, I'm not showing the same thing repeatedly over there. So what I'm gonna do, I'll show you some more connections because we have a lot of to cover, as I said. Let's say this is a floor beam coming over here, and we usually put some sort of shear plates. So let's put some shear plate, select these two beams, press space bar. So as you know that I didn't change it for the first time, but that's okay. If something is coming like this, you can select over here and say shear plate, and there it is, the shear plate, and your shear plate is placed easily. Again, it's a matter of just changing. I'm gonna do it for you. So come over the edit parameter, and let's say over here in the plate section, plate layout, probably that's not the thing. I'm looking for vertical bolting. I have the default is taking as a vertical bolt of 3. I'll be putting 2, and there it is. I need to do a bit of more adjustment, like 50 mil from the top, and there it is. Probably this is the perfect connection you're looking for. Select OK and press apply. It's always better if you duplicate it, because if you want to replicate some other places, you can do this. Now you already got the idea. Select it, propagate, and propagation will done in the same condition where this beam and the floor beam exist. It will replicate all over the places. Now, upon this, I'm gonna show you some different connection over here where the tank is attached. Let me hide this tank, otherwise it's coming on my view, which is pretty annoying sometimes. Let me hide temporarily, and let me show you that how can you use different method to connect these beams together. All right, let's do it. Connection, and over here, I'll go for shear plate with splice. Let's say it's a different kind of thing. Engineer has asked you to put some shear plate with splice. You can also do this. Select two beams, appropriate beam, spacebar, and there it is. My shear plate is placed. Now you also have the option to place some sort of stiffener on the other side. Now it's just a matter of playing around with the settings. I'm not getting too fussy about this one because you got the idea. You can play it, and it is just very nice and very easy to work with. I'm going to show you just one thing, that if you select it and if you go on the other side, let's select it and you want to watch it from here. It says stiffener and opposite side. If you want to put some sort of stiffener, just click it and there it is. My stiffener is here. Okay, great. Oops, I canceled that one. Okay, you got the idea how to play the stiffener on the other side. You also have a bunch of settings, whether you want that in the same line or perpendicular to the primary member. You can play around with this all day long. All right, great. The next one I would like to talk about over here, which is tube connection. Let's say because of the project requirement and engineering calculation, we have to put some sort of bracing like this on all sides of the tank so that it can sustain the load, horizontal load, lateral load, whatever you'd like to say, earthquake load, and we have to put some sort of bracing like this. Now I'm going to choose some sort of different connection, which is called tube connection. And I will use this tube connection with two diagonals. First of all, you'll be selecting the member and then the bracing connections like this, and press spacebar, and there it is. It has placed with some sort of plate, shear plates and other stuff, and it has notch and cut all the members perfectly to match the need. Now, again, this is the default settings that you're seeing right now. You have to just play around with the settings and you'll get the job done. Again, you can use this in a multiple places. Let me show you. If you select one connection, then go for the create similar, select 1, 2, and third one, press spacebar, your job is done. If you don't want to use it in this way, for example, I'm going to show you a different approach, that how can you place these connections easily. If you don't want to replicate, let's say we want to place connections over here. So connection, and you can do one thing over here. You can place a generic connection first, GENA, generic connection. You select these, and it's going to record the generic connection like this. And again, you can do the same over here. And then if you have done this connection somewhere else, let me do it. Otherwise, I'll be missing something. Let's say this is the connection. Sorry, I missed something. Select, select, and select, press spacebar. Let's say I want to replicate this connection in 2 places like this. So the easy way is you select these 2 connections, and from the drop down, you select the connections, job will be done. Or what you can do, you can match the property. Like you are an AutoCAD user, you know that there's a match function. I'm using the same function, selecting this connection and selecting multiple. 1, 2. If you have many, just select them, press finish, and press modify button, and job done. So very nice, very easy to use. You just have to know where to use and how to use it, what are the parameters are, how to control it. Probably there could be some sort of limitation, but that's a different issue. But most of the time, this is just a pretty much straightforward way to do these connections. Okay, I'm moving to the to something new over here, which is this bracing. As I said, that this model was borrowed from the first webinar. At that time, we probably haven't put any bracing over there because of the time constraint. Now, here I have modified something on this project. I put some bracings, and now I'm going to show you how to put some bracing connection when it's angle connection, when the bracing members are angled, not like previously on this one. These were tube, but these are bracing right now. Okay, great. I'll go for the connection, and I'll choose a connection which is called gusset. Select the gusset, and there it is. My gusset connections are here. Let's see, I want double gusset brace plate. Select my primary member, select the bracing member, press spacebar. There you go. My gusset has placed with a different arrangement because this is meant to be a double. Okay, this is a tube brace plate. Okay, no worries. I'll change it to the different one, gusset brace plate. This one. All right, perfect. I'm looking for this one. As you can see, the change is just pretty much easy. Select it from the drop down list. Which one do you want to use? Just use it, and everything will come up in front of you. The only matter is how do you modify the parameters. Let's say I want to replicate this one into multiple places. Okay, let's not do this because for the time constraint, we can do this. I'm going to show you some different conditions over here. Let's say there's another connection you can do with the column to the bracing, and that is basically called, if I go to the gusset, G-U-S-S-E-T, and gusset to diagonal triangular. Okay, let's do it. Select column, select bracing, press enter, and there will be a triangular plate over here that is placed nicely. Now, if you're not happy about the bolt settings, bolt size, bolt location, you can change it by going to the modifier of the parameters. Great. So you can again replicate on different places. I'm going to show you a different arrangement over here you can apply, which is, let's do it like this. Select the column, select the bracing, press spacebar. The same triangular plate was placed here, but if you just come to the drop down, and you may have some different arrangement, which probably your engineer doesn't want to use that triangular shape. You have some different shape, you can switch it easily. And if you have the multiple condition like this, then you can just select all of them, like I have already showed you in case of purlins. Select them, right click, and everything will be done. Get the next one I would like to show you. It's an interesting one. Let me hide this for the time being because these are coming on my way every time. All right, the last thing in this place, what I'm going to show you is just let's say these are the angle bracing, and these are placed back to back. We have a wonderful connection system which is called direct bolting. Come to the connection and look for the direct bolting. Direct bolt, there it is. Select the direct bolt, select 2 members, press space bar, and there it is, a bolt is placed. Now I'm going to the parameters, and over the parameters, I'll change the bolt distance 40 instead of 70. I'll go for 45. If I just change this 45, as you can see, it will come up at the center. Press OK, press apply, and there it is. Now, if anyhow the connection, if the structure changes, it will gonna adopt automatically. Now, the last bracing I'd like to talk about, which is this one, which is basically a tension brace applied over here. And if you can remember, this condition of attaching three member is also the same like this. Three members, primary and secondary members, are connecting. And in case of this tension brace, it's also coming in this way, that we have a primary member and two secondary members are coming. So you can also apply this principle and this connection on this place. Let me show you how to do it. Select it, press the create similar button, and select these two. Press spacebar. As you can imagine, it will come up with the bolting and everything as the connection exists. Now, what I'm gonna do, I'll select it, and from the drop-down list, I already have created something for this rod. Select this rod just by changing the parameters, thickening the plate thickness, and it's just welded to the main beam, and the rods are coming and welding over here. And the same thing you can do on the other side, where one primary member and another secondary member is coming like this, which is some sort of situation over here, or just the triangular situation. Okay, let me do it for you so that you can understand how does it go on. Select the beam, select the bar, press space bar. Definitely this is not the ideal condition, that's why this warning message came out. So select it, and from here I have already created some connection for the rod. So if I type down rod, there it is, diagonal triangular connection, there it is. And as you can imagine, right click, propagate, it will be propagating on every single where this similar condition occurs. Right, okay, I'm not proceeding with this one. I'm gonna show you something different. You got the idea that how to replicate, how to propagate, and how to modify the connections. I'm gonna give you some different structure, which we have already worked out. Let me bring it to you. Okay. Okay. This is another structure. As you can see, it's a hangar facility for the aircraft. So I modeled this not by going one by one member. I use the truss tool in the structure tab, in the structure section. You have the truss tool. I just use the truss tool, and then I exploded the truss tool, so that I can get the members in the right shape and size. Now, before you explode this, or before you remove the truss system, you have to be very specific that what you need, it's already there. Otherwise, you have to do the manual work. All right, great. So these truss members are made of pipe, as you can see, CHS, or pipe, whatever you'd like to say. Now, because of the project requirement, let's say, let me go to the section view so that you can understand. Because of the project requirement, let's say this is a very big truss, and it cannot be transported at once. Probably engineers has decided to break it down over these places, and we have chopped it out. And then in the 3D view, we already, you can already have seen, we have some cool connection, which is the tube end to end. This is the same connection system I'm using. I'm not using any kind of different method. As you can see over here, everything is loaded. So tube end-to-end connection exists here. So you just have to explore, select, and apply. And there it is. My tube connection is applied. So I also replicate the same thing over four different places of each truss, as you can see. And I made and I have just colored this up so that the things can be understood by the fabricator when they are fabricating, that okay, this is a different part and that's the other part. Now I have to chop this out to separate from the other part of the structure. So we placed an front end splice base plate end to end of this member, and I have created two different conditions. If you want to explore, this is the bigger one and this is the smaller one. So you can prepare everything, and then you apply a proper condition. All right, the end of the truss is just applied as a, these are basically end plate with bolts, and that's mostly used in the railing. Now, you might be imagining that why did we use the railing condition over here, but that's not the case. If anything similar you find, you just apply it, and that's going to be applied very nicely over here. So endpoints are connected by the plates and bolts, and this web member is again, it's the same situation, diagonal uh, gusset plate with one diagonal, and you can, I just put the bolt over here. If you want, you can remove it and weld it directly. Great. And in some cases, for example, over here, we put some horizontal lateral bracing, and two types of connection I have showed over here, which is tube to tube brace with gusset. And on the other side, I used a simple uh, four connections, gusset plate for three diagonals. As you can see that different connection was applied, one with the T bracket, as you can see over here, and another one is just simply putting them on a plate and just bolting them as much as you want. If your project says 3 bolts, 4 bolts, you can just apply. Your plate size and shape will adopt automatically. All right, great. The last part I would like to talk about, if I just close it, the last connection, which I haven't applied over here, but there's another project we have been working on where this is the bridge project. I already talked about this one yesterday. The optioneering, the title was optioneering with Revit, conceptual optioneering. So you can watch this. How did we uh, give a different proposal with the options chosen from the structural point of view. So I'm gonna hide this one. And as you can see, this was the platform, and these are the edge beams, and these are the I-beams, and two different I-beam was attached with the splice, and that this was not the actual default configuration. I have to modify this one to make this according to my requirement or the engineer's calculation. So as you can see, very nice, very easy to work with. And the last thing I would like to talk about, if you want, if you have some situation like this, you have a gusset plate and you want to put a plate with the bolt, you can also use this connection, and that's called four diagonals middle gusset plate. All right, great. Now, one thing I'd like to talk about, that enough talk about the connections. Now, the last thing is how to document this one. Uh, Once I go to the base plate, I have already placed my view over here. If I double click on my view, it's going to open up. And over here, let's say I want to do some dimensioning, and let's do it very quickly. Let's say I want to put some dimension like this, overall dimension as well. Anchor to anchor dimension. Now, if you are struggling with the anchor dimension because you cannot find any reference, then the easy and live trick is go to the wireframe preview, and that's how you'll be able to detect the center line of the anchors. So dimension, there it is. My center line is detected properly, and there and there. Place on the other side as well, like this, like this. Definitely, some of you may have a struggle with this one, that how am I gonna detect these anchor centers, and that's the cool trick I just shared with you. All right, going to the hidden line preview, and I'm activating my thick line preview, and there it is. As you can see, my documentation done. I want to place some sort of tag. For example, I want to know that this is not the only thing I want to see. I also want to see how is it placed in terms of tagging, like all the information. Sometimes it's really hard to input in one drawing. So you can call the tag. I'm calling the tag, and I'm hovering over my plate, and there it is. It's already selected the plate. If I click on the plate, it's going to show me that what is the plate name, secondly, thickness, and what kind of material was used. Now, this is basically a standard tag. If you want to customize, you can double click on it and you can customize as much as you want. We already talked about the customization in the second webinar, I believe. And then The next part you want to do tagging. This anchors, let's say these are the anchors. Excuse me, I forgot to place my tag. All right, tag tool is activated, and there it is. It's showing me 16 mil 4.6 holding down bolt was used over here, and you have the option to just place it at the hold down bolt anchor, and there it is. Now, the one wonderful thing is working with the connection. If anything changes, for example, I'm going to show you if I change this base plate over here. Let's say our projection was, if I can remember, our projection was 100. Now, all on a sudden, engineer has come up and said that, okay, I don't want 100 mil projection all through. Can you reduce it? Okay, yes, for sure. Reduce it to 75, and watch what happens once I click OK, apply this change. Press OK and press apply, and there it is. As you can see, my plate has shrunk, and that's giving me real-time update without doing any line work, without doing any manipulation, going to the doing the repetitive work that we usually go on doing in AutoCAD. Now automatically it's done. Now last thing I'd like to show you over here, let's say this plate thickness was changed to 25 mil. If you update 25 mil plate and press OK, and now as you can see, when I press apply, this plate is reading 25 mil plate. So there is a less chance of anything mismatch on the information. Whatever information you put over here, if you put your tag properly, then every information will be counted properly. Let's say I want to reduce the distance between the anchors. Uh, I want 350 anchor, sorry, 350. On the other side, let's say 175. That's okay. I can just leave it for this. Press apply, apply. As you can see, my anchor is also reading 350 and 175 on different directions. All right, great. Last thing I'd like to show you, if you go to the view over here, as you can see, I want to document this one. So double click, my view is open. If I want to dimension, I can clearly dimension. Let's say I want the overall plate dimension like this. I want end-to-end dimension from corner to corner. I'm switching to edge to corner right now by pressing my tab key, and there it is. Now if I want to place some dimension over here, already I have talked about that. If you cannot see this, if you cannot see the center line, go to the wireframe, and that's going to detect your center line. There it is, my centers. There my centers are, and place it. And that's how we prepare our drawings very easily. I'm going to do some more dimensions over here so that you can understand. There it is. Now all on this, okay, let me put some tagging so that you can see how it is responding. Let's say this is tagging. Now all of a sudden engineer has changed the design again. Let's say instead of 20 mil plate, they have changed to 25 mil plate thickness, or 16 mil plate, let's say. Now it's going to update automatically in my system. Apply, and there it is. It's already applied to 16 mil plate. If you change any other parameter over here, it's going to reflect automatically in your drawing. Now it's just a matter of creating over a sheet, and then place the design, and job done. This is the detail file I'm working on. So whatever detail you're working on, it's going to show up in a bold color like this. Okay, great. So I hope I could be able to give you some valuable insight regarding the use of steel connection with Revit Structure, which are procedural in nature, and it can minimize a lot of time at the time of documentation. And thanks again for joining to this webinar. I'm done with my part. I'm going to pass it to Ben now.
Great. Thank you so much, Asif. That was certainly a lot of really good stuff that came through there. Let me just quickly jump back into mine. Hopefully everybody can see my screen now. Look, I appreciate we are a little bit over time, so I'll try and wrap this up fairly quickly. So look, what we showed today was obviously a lot of use cases and different types of connections that are available through Revit. As you saw, these can be loaded directly out of Revit itself, and then obviously edited for individual connection parameter settings as needed. We showed how easy it is to custom, or to, I should say, customize in this sense, to change those parameters for individual connections, which obviously then reverberates around to all the associated connections as well. And as you saw at the end there, drawing production is very intuitive and automatic on the side as well. Look, a note I've got there at the bottom, and this leads into my following slide, which is question time. But look, custom connection building in Revit is a whole nother topic that we chose not to get too deep into today, simply for time constraints. But look, based on a lot of the questions we had through, I think there's certainly scope for a dedicated customized connection presentation. So we'll certainly discuss that internally and get something like that going in the future. But look, essentially with custom connections, that is rather than using out-of-box connections, we can essentially develop the background or the connections from scratch, including adding our own custom parameters into those connections. So if you do, I alluded to before, a lot of organizations have a lot of, or a DWG library of typical connections they might use. Look, we can work with you to create some customized connections which would mimic them within Revit, if that is one of your hesitations. Further through advanced steel and some other modules, there's even more availability or functionality that can be provided there as well. Thank you everybody for joining me, or joining us, I should say. Thank you very much to Asif for his wonderful presentation today. If you did want to get in touch about anything you saw today, or about any of customization support or anything you might need for any of this, please get in touch. My email address is there, phone number, website, everything is there. Please do not hesitate to get in touch. Otherwise, thank you everybody again for joining us today, and I hope you all have a wonderful afternoon. Thank you.